Look at it. A tiny speck of light lost at the edge of everything. For 76 years we called it a planet, the 9th planet, the last stop before the void. Then in 2006 we erased it, demoted it, stripped it of its title in a vote that lasted less than an hour. This is Pluto. We called it a dwarf, a piece of dead space junk, a mistake, a rounding error in the outer solar system that never should have been counted in the first place. We threw it away without a second thought. But here is the thing about Pluto. Pluto does not care what we call it. It never did. And when we finally sent a camera 4 billion miles into the dark to see what we had thrown away, what came back changed everything. Not slightly, not in the way scientists quietly revise a model in an academic paper. Fundamentally, completely, in the way that makes you sit down and stare at the ceiling and wonder what else we have been wrong about. Imagine the journey first, because you need to feel the distance before you can understand what we found. You leave Earth, the planet shrinks behind you in hours. The moon is gone in seconds. Mars slides past on your left. Jupiter looms ahead, enormous and churning with storms the size of continents. And then it is behind you too. Saturn with its rings. Uranus tilted on its side. Neptune, the last giant, dark blue and freezing at the edge of the planetary zone. And then you keep going. For 9.5 years you keep going. At 50,000 miles per hour, which is faster than any bullet ever fired by any weapon ever built, you keep going into a darkness that gets deeper and emptier and colder with every passing day. The sun behind you gets smaller. By the time you reach Pluto, it is not the warm yellow star you know from Earth. It is a bright point, a pinprick, just another light in a sky full of lights, and not even the brightest one. There is no warmth coming from it, no heat you could feel. If you stood on Pluto at noon, at the moment when the sun is directly overhead at its highest point in the Plutonian sky, the sky around you would be pitch black, not dark blue, not purple, black, permanent, absolute, star-filled black. This is where we sent our camera. This is what we pointed our best instruments at after 9.5 years of travel through the most hostile environment in the solar system. And this is what came back. A heart, a giant white heart shining in the darkness. The image went around the internet in hours. People called it cute, a love letter from the edge of the solar system, the little dwarf planet sending us a valentine. But do not be fooled by the shape. Do not let the familiarity of it make you comfortable. That heart is not love. It is a wound. And when you understand what is actually inside it, what is moving inside it, what is buried miles beneath its surface, the word you will reach for is not cute. The word you will reach for is terrifying. That heart is a crater, not a small one, 1,000 miles across, carved into Pluto's surface by something enormous that struck it billions of years ago with enough force to reshape the entire planet. The impact gouged out a basin so deep and so wide that it covers a significant fraction of Pluto's entire visible hemisphere. And that basin did not stay empty. Over billions of years it filled, not with water, not with anything you would want to touch. It filled with frozen nitrogen, methane, and carbon monoxide, a glacier made entirely of chemicals that would destroy your lungs and freeze your blood in the same instant, a white sea of poison stretching from horizon to horizon, 1,000 miles of it, sitting in a wound that never healed. But here is what makes it stranger than just a toxic glacier. It is not still. Deep beneath Pluto's frozen surface, buried under layers of ice and rock, there is heat left over from the violent gravitational compression of the planet's formation billions of years ago. That heat is faint, barely there, but it is enough. It rises slowly through the rock and ice, and when it reaches the bottom of the nitrogen glacier, it does something that should not be possible on a world this cold and this far from any star. It makes the nitrogen boil, not violently, not explosively, slowly, gently, the way water barely trembles at the bottom of a pot on the lowest possible heating setting. The surface of this glacier is turning over, renewing itself constantly, erasing itself and beginning again in a process process that has been running for billions of years and shows no sign of stopping. This is why New Horizons, when it sent back its photographs of the glacier's surface, there were no impact craters anywhere on it. None. In a solar system that has been bombarding every surface with rocks and ice for 4.5 billion years, this glacier has 0 craters, because every crater that forms gets swallowed, dragged down into the churning interior, dissolved, erased as if it never happened. A white sea that eats everything that touches it and shows no evidence that anything ever did. Now look at what is surrounding that glacier. At its edges, where the frozen nitrogen meets the harder terrain of Pluto's broader surface, mountain ranges rise. Not small ones. Mountains reaching 3,000 to 3,500 meters above the surrounding terrain, with sharp angular peaks and steep flanks that catch the faint distant sunlight at angles that make them look like broken glass. On Earth, mountains are made of rock. On Pluto, it is so cold, so permanently and profoundly cold, that water ice does not behave in the way it does in any environment humans have ever lived in. At Pluto's surface temperatures, ice is harder than granite. It is rigid, strong, capable of holding a sharp edge for billions of years without erosion. Those mountains are not stone. They are frozen water, solid ice so cold it has become harder than the rock that forms the mountains of Earth. And because ice is less dense than the nitrogen it sits in, these mountains do not simply rest on the glacier floor. They float. Enormous ranges of frozen water ice, peaks covered with red dust, drifting with geologic slowness across a sea of liquid adjacent nitrogen, in a motion you could never observe in a human lifetime, but that the geologic record of the glacier's surface confirms has been happening for as long as the glacier has existed. Mountain ranges the size of the Alps, drifting silently across a poisonous sea, moving toward you with the patience of geology and the indifference of physics. And the snow on those peaks is not white. Look closely at the photographs, and the color that covers the highest elevations is red, a deep rusty red that stains the peaks of every floating mountain range in a layer of dust that falls continuously from the sky. When the sun's faint ultraviolet light reaches Pluto's thin atmosphere and strikes the frozen methane molecules suspended there, a photochemical reaction occurs. The methane molecules break apart and reassemble into complex organic compounds called tholins. They are reddish-brown in color. They are toxic, and they rain down on every surface on Pluto in a slow, continuous fall that has been going on for billions of years, covering everything with a layer of complex organic chemistry that gives the planet its distinctive coloring and makes its mountains look as if they have been soaked in something dark. Pluto bleeds from above, red organic snow falling forever on floating mountains of frozen water, drifting across a churning sea of liquid nitrogen in a crater the size of a continent, under a black sky where the sun is just another star. And then there is what is underneath it all. This is where the story stops being merely strange and becomes something that sits at the back of your mind long after you have stopped thinking about it consciously. That glacier, 1,000 miles across, filled with frozen nitrogen, is extraordinarily heavy, and physics says that a mass this large sitting on the surface of a planet should have consequences. The gravitational influence of that concentrated weight should have caused Pluto to slowly reorient itself over millions of years, rolling until the heaviest surface feature sat at the equator, where the rotational physics of the planet would be most stable. This is a well-understood process. It happens on other worlds. It should have happened on Pluto, but it did not. Pluto did not roll. The glacier sits where it sits, off-center, away from the equator, as if something is holding the planet in place against the physics that should be moving it. Something with enough mass and enough gravitational influence.
It came through at 22.4 hours after the last scheduled transmission window. Not a malfunction alert.
report. Not a systems error, a signal. Clean, structured, and unlike anything Voyager 2 had sent back in its entire 47-year journey through space. The engineers at the Deep Space Network who first received it did not immediately tell anyone outside the room. They ran the decoding sequence 3 times. They checked the timestamp against the orbital position data. They verified the signal origin against the known trajectory of the spacecraft. Everything confirmed the same thing. The signal was real. It came from Voyager 2, and the data embedded inside it described an environment that nothing in our current models of the outer solar system had predicted would be there. By the time the analysis team had assembled and the senior mission controllers had been notified, 6 hours had passed. The data was being processed in fragments across 3 separate institutional servers, and somewhere in those fragments, buried in the telemetry of a 47-year-old spacecraft running on a nuclear battery producing less power than a refrigerator light bulb, was a measurement that changed everything we thought we knew about what exists beyond the edge of the solar system and what might be waiting in the darkness on the other side of everything we can see. Voyager 2 launched on August 20th, 1977, 47 years ago, when the most powerful computer on Earth had less processing power than the phone sitting in your pocket right now. NASA engineers calculated a trajectory so precisely that it used the gravitational fields of Jupiter, Saturn, Uranus, and Neptune in sequence to accelerate a small spacecraft to a velocity that would eventually carry it out of the solar system entirely. The planetary alignment that made this grand tour trajectory possible occurs only once every 176 years. They had one window. They hit it perfectly. Voyager 2 flew past Jupiter in 1979, Saturn in 1981, Uranus in 1986, and Neptune in 1989, becoming the only spacecraft in history to have visited all 4 of the solar system's outer giants and returning images and data that rewrote planetary science at every encounter. And then it kept going, past the Kuiper Belt, past the scattered disk, past the heliopause, the boundary where the solar wind, the constant stream of charged particles flowing outward from the sun, finally loses the battle against the pressure of interstellar space and is pushed back. In December 2018, mission controllers confirmed that Voyager 2 had crossed the heliopause and entered interstellar space, becoming only the second human-made object in history to leave the solar system, following Voyager 1, which had crossed the same boundary 6 years earlier. Beyond the heliopause is a region scientists call the very local interstellar medium, the space between the stars, the true darkness beyond the solar system's protective bubble. And it is from this region, from a distance of more than 12 billion miles from Earth, that the anomalous transmission came. To understand why what Voyager 2 detected is so significant, you need to understand what the heliopause actually is and what it was expected to protect us from. The solar system exists inside a vast bubble of charged particles and magnetic field created by the sun's constant output of solar wind. This bubble, called the heliosphere, extends outward from the sun in every direction, pushing back against the interstellar medium, the thin sea of gas, dust, magnetic fields, and cosmic rays that fills the space between stellar systems. The boundary where the solar wind's pressure finally equals the pressure of the interstellar medium is the heliopause. Inside the heliopause, the environment is shaped and dominated by our sun. Outside it, the environment is shaped by forces entirely independent of our solar system, forces whose origin lies in distant supernovae, stellar nurseries, galactic magnetic field structures, and processes operating on scales of thousands of light years. Before Voyager 1 and Voyager 2 crossed the heliopause, everything we knew about the interstellar medium beyond it came from remote sensing observations and theoretical models.